So guys, welcome to the practical machine learning series. This is lecture 3 and today we will be mainly looking at basic data selection using pandas. So let's look at today's agenda. So guys, today we will start with what is data selection. Then we will load our data. We will then look at different ways in which we can directly select our data, which is general based selection. And after that, we will look at method based selection, which is loc and iloc based selection. It is pretty important for a data scientist to know this thing because it will help you a lot later on. After that, we will look at a specific way to use loc and iloc, accessing new data frame values using loc and iloc. And finally, I will be giving you some homework for later practices. So let's start today's session. So first thing first, what is data selection? So data selection refers to the process of selecting or accessing desired columns, rows, or observations from a data frame. So most of the time you will not be working with the entire data set. You will try to find most relevant features, and for that you should know how to access desired column, rows, or observation. And there are multiple methods to select the data, some being simple indexing, which we say as matrix based selection, and some being the method based selection, which is loc and iloc. That's for the data selection part. Now let's load our data. This is kind of a brief from the lecture 1 video. So as you remember, we were using the diabetes dataset from the sklearn dataset API. So I am loading that diabetes as a data frame because of this as frame is equal to true method. And then I am taking the data attribute of the diabetes and passing it to the data frame so that we can later on work very easily. We don't have to access data each time. And lastly, if I do df.head, you can see that we have our data frame. Now, before moving ahead, I want you to understand two things, guys. First of all, that this particular column names are index and they are called column index. And this particular 0, 1, 2, 3, 4, these are called row index. And as you have seen that this particular indexing, based on the number, they start from the 0. After that, this particular indexing also starts with 0. Now I have made a small thing here that I want to show you. First one, as you can see, it's a column index which starts from 0. And this is our row index which also starts from 0. And when we intersect them, we get the observation. To give you a perspective, this particular observation, you can say that it's the intersection of column A's and row index 0. But in column index thing, you will say it's column 0 and 0. So this is 0, 0, kind of like how you treat 2D matrix. So this thing you need to keep in mind before moving ahead, because later on we will be using this extensively and it will become harder if you don't understand this simple analogy of indexing. Okay, now let's move on to general selection methods, which is list or matrix based. Now in general selection, we have selecting single columns and observations of a data frame, selecting multiple columns and observations of a data frame, and how to print columns of the data set. Now this is very important because here it is a very small data set, but in general you have 1,000 or maybe 10,000 of columns, that is features. Then how will you check that? So we have this column attribute that we can apply on our df and print it, and you can see that it returns an index which is this particular column name. Once we have this, we can directly move on to selecting our single column or observation in a data frame. Okay, so the basic syntax for that is, first of all, you need to pass the column name and then the row index. And note that indexing will always start from 0. So if you want to access a particular column, how you will access? We have seen this many times, right? You can directly put in your column and say I want to access the age column. I am just putting df and then age. Now this will return a series, not a data frame, because as you have seen from the lecture 1 or 2, the multiple series makes up a data frame, right? So let me show you the type here. You can see that it's pandas core series.series. But why it is important to know this? Because that means you can only use series methods on this particular column. So now if you see here, we have 442 observations, 0 to 441. That's why, okay? And each of them are float 64 because they are floating point numbers. Okay. Now let's say you want to access this particular value. So by default, it says row 1, but see the row index value, it's 0. So you need to pass that 0 after that. as per our row index value, right? So here I have just passed that. You can see that it's df age and then I have passed the row index value of 0. So this thing will return a float 64 and it's a numpy array. Okay, so these individual values can be accessed. Now let's say I want to access 437 value, but here if I want to access 437, you see that you have just given the row index. So by default you have to use this row index everywhere whenever you are using this particular indexing. Now say I want to get continuous list of values. So it's very simple. Just put in your column name. So this data, this BMI column, I want to get the values of the first 10 observations. You can directly do this using BMI, and then if you remember, we have this list based indexing method, right? So you can directly use this colon, that means all the values till row 10, and this will be excluded by default. Okay, if I run this, you can see that it says all the 9 values which are present. Now coming to this 437 to 441, what I can do is I can directly pass in this 437 row index to 441, obviously. So 441 will be excluded. I want that it should be included, so 442, and maybe you can find that we have all these values which are similar to that. Apart from that, in head method you can only specify till value, means the end index, not the start index. So if you want to get a subset, this is very helpful way to do that thing. And again, remember, indexing starts from 0, that's why we included this 442 and not 440. And this is the syntax of this particular method. We have to write the column name inside the df, then we need to pass in the start index which will be included while printing the answer, and end index which will be excluded. So you can use this particular method which I just showed you to do this. Okay, now let's say I want to get subsequent values for a particular column, values for the column BMI, that is last 10 values. So what I can do, I can just pass in BMI as the column name, and row value last 10 we can access using the negative indexing, if you remember, right? And then we have this column, that means all the things after the minus 10 values. And if I print it, you can see that we have 432 to 441 values. Now if I want to select a specific range of values, I already showed you how to do that, but here I have done it for S1 column, basically this particular. And what I have done is I want to get the values from 152 to 49. Okay, so you can see that we have this value. Always remember guys that this indexing thing works on zero based indexing. So that's for how to access single columns or observations of a data. Now, if I want to select multiple columns or observations of a data frame, how can I do that? So, multiple columns requires a little bit of changes here, because this can be considered as a 2D matrix, you can think of it. Here we have our column names in a separate list. This is very important to access multiple columns, and it's a very shortcut trick. Now, if I do this, you can see that I have only the 3 columns that we require, and I have used this extensively later. So make sure that you understand. Okay. Now you can see that we have again 442 rows and 3 columns. And this is a simple syntax of this df column. Column name just means a list of column name. Now if I want to access a specific value or observation which are same, means basically they have the same index, then how can I do that? I can use this particular method df, again same, passing the or the list of column values and then getting the first 10 observations. This is for the start index. So all the values that are present before the 10th row index will be printed. So this is very useful. Now I want to get a value from 3 to 6 only. How you will do that? For that you need to use this indexing, and let me show you how to use that particular. To do is I am going to again copy this particular thing, paste it here, and then from 3 to 6 I said so 3. If I want to include 6, I have to write 7, right? So we can directly access a subset of data, and this is very important guys for later use cases when we will be looking at Intuit machine learning pipeline, which we will be covering soon. Say I want to access 330th row value for age and S3. Can I do that? Let's check. And you can see it throws a key error that 332, 338 is not present. So it's surprising that you can't do this. And for this only, we have this loc and iloc with selection that we are going to see next. So guys, now comes the most important part of this video, which I want you to understand very clearly because that will help you a lot. That is loc and iloc based selection. So what does loc and iloc mean? So loc means location and iloc means integer location. And as the name suggests, loc allows you to use column names while indexing and row indices. While iloc doesn't allow you this column name thing. You need to always use integer while using the column. Again, both use the row index and column index. But in one, you need to use the name of the column, and in second, you need to use the index value. And indexing always starts with 0. Make sure with that. So here, let's say we want to select single observation based on row and column index. So first of all, we need to check what is our data. As you can see that here we have our column index and here we have our row index, and each individual value is observation. That's kind of a recap there. And now say I want to access the 10th observation across all columns. That means that I want to access this particular row. Okay. What is the index here? It's 10, right? So that means that we need to pass in 10 here for the low. Now if you see, it returns a series object. Basically what it did was it found the 10th index value for all columns and returned that. And you can see that we have all these values. So let's match them. Say first value was minus 0.096328 and this is the value, and last value is 0.034215 and this is the value. So that means we are good to go here. Now for iloc, again it will be a row based indexing, and if I want to access say 10th value again, I can use here. Now one thing is that in iloc you can't use this age column that we can use here. Okay, let me show it to you. You can see that age is not defined. Why? Because our row index doesn't have this age thing. It has this 10. So I have to pass in this 10 here. Okay, so if I pass in this 10, you can see that again we have similar values. Now one thing to be very clear guys here, that this works because our indexing starts from 0. Had it been started from 1, then this thing will return an error because 0 was not present. It would be 11th, and then if you want to access this particular thing, you need to pass in this 11th value, not the 10th value. And for the loc, you need to pass in the 10th value here. Okay. Now say you want to select multiple observations using loc and iloc. How can you do that? And here the things will start getting clear guys. So if you want to access a specific value or element, then you can use df.loc, our row index and column name. And this is the exact row index guys. That means whatever written here, that only. So most probably it will return this. Let's check it out. If I do this, it's 0.8529. So let's see where we are getting this. And you can see this. As I said, it will return this. Why? Because it is at the intersection of age and row index 2. But if you want to access the same thing using iloc, you can't use this age. You need to use the column index there. And column index again starts from 0. So rather than using the age name, you can only use the 0th value there. And if I do this, I will get the value. But if I try this here, then it will throw an error to me saying that location based indexing can only have integer value or integer slice. So that's the difference of loc and iloc. Now, if I want to access same row values across multiple columns, how can I do that? So, if I want to do this, I have to first of all pass in the row int. Basically, I want the second row for all these 4 columns. And as I printed it using shift enter, you can see that we have all these values for the second row. Let's verify that. For the second value, it's 0.298051. Let's see what we are getting here. 5. Yes, we are going good. So each time I have to write the column name. Say I have 100 columns that I want to write. Will you be writing everything there? It is very hard to write. So we can use iloc there. If I want to use iloc, pass in this 2 comma 0 is to 4. That means that give me the second row for the column which are indexed at 0 is to 4. That is these 4. And again, this will be ignored. So I have passed in extra column index. Okay. Now if I print this, you can see that again I am getting the same values as earlier. So this is very good way to do things. Now guys, let's say I want to access multiple rows across multiple columns. Say I want to access second to fifth row values across columns 0 to 4. That is age, sex, BMI, BP. And here I will be passing the row index of 2 is to 5 because fifth value I want, right? So it will return from 2 to 5. So now here we are using iloc rather than log. Again, we can't use the name of the column, so we are simply passing the column index. Now you can see we are only getting 2, 3 and 4. Now let's say you want to access a specific set of value for a specific set of columns. So how you can do that? It's very simple. Again, here I am going to show you using loc and iloc. So first of all, we will go with iloc. So iloc 2 is to 5, 1, 3, 5. So you can see that these are all the 3 column indexes that we wanted to know. And these are nothing but our 3 columns, sex, BP and S2, right? So same thing. And again, we are getting the second to fifth values. And since end index is excluded, so we need to pass in this. Then I am comparing it with loc. So here I am just passing it this row index, that is 2 is to 4, because we want to include the fourth value. Again, we are passing the column name where earlier column index for us. Now they are column name here. And here end index is included, and this is very normal. And you can see that we are getting the same value. Here we need to pass in this 5, but here we are good with 4 only. So this is a major difference that you need to make sure. And you can see that here I have written iloc specify only integer values and end index is excluded, while loc specify integer as well as string values, which are basically column names, and end index is included. That's for selecting multiple observations using loc and iloc. Sometimes what happens is we want to select or access based on certain conditions. So loc and iloc plus normal method plus conditional arithmetic operators can be used here. And major uses of iloc and loc is this only, that if you want to select say even number of columns or odd number of columns, how you are going to do that. So first of all, we will check the describe. Why? Because we are going to use values from here for our conditional selection. So say I want to access all rows where BP is greater than 50 percentile. Here I am just taking DF and giving it a condition that BP is greater than this particular value. Now let's see what it returns. You can see that it returns a series of true and false. Using filtering, we can do this like this, right? Now we have only those values whose BP is greater than -5. So now we can use this, or there is an alternate method. We can use this using the loc. So using loc, we can create this particular condition, and then rather than passing it to DF, we are going to pass it to loc. Why? Because it will return row indices, yani these values, right? 439, 440 and everything. All those values will be here. And now if I do this, you can see that we have these values 0, 4, 7, 10, 13. And here also we were getting the same things. Now we can also store this because this is a copy. If you are going to see the actual data frame, it will be different. So you need to store it somewhere. So to store it, we created this BPDF filter, which is again a data frame. I have stored all the values of the data frame that we created in BPDF filter, and now I am in it. So that's 209 rows and 10 columns. Index of original data frame is returned, not the shifted ones. This is very important. This particular index, which has been returned here, is the index of original data frame. So if I do df.head for the fourth value, what is this? And here what is? So same indexing is there, right? Fourth index, and here also it's fourth index. The benefit of this particular method is that you can take multiple filtering conditions and pass into this loc method, and you will get the index back. However, For this particular thing, you need to write separate statements and then merge them using bitwise AND or selection operator. So this is very important. So guys, now let's say you want to access entries present on the third position using loc, that is location. Now, as you can see here, third index is not present. By third index, I mean this particular 3 is not written anywhere. So that means that we will get an error because loc basically used this particular numbers to access it and it was not present. So we got that error. However, we can use iloc in this case and get the right values. So using iloc, I can directly get it. Why? Because when we are using iloc, this whole thing is actually indexed from 0, 1, 2, 3. So third value will be 0, 1, 2, 3. This particular value was returned. And this is a kind of interview question that they ask in general. Now let's move on to homework. These are your homeworks. How many columns are present in diabetes dataset? What is the value of 20th element of S1 and A's column? What is the value of 23 to 26th element rows of 1 to 5th column? Answer based on loc and iloc. Find all the row or row index where S1 is greater than this and return the third observation of S1 value. Hint, use loc filter and loc indexing. You can use both. Find all values where S3 is less than this particular value and store S3 filter and find the third row value using loc and iloc. Are they same? And this is optional that you need to combine this two filtering condition and find all the rows. So what I want you to do is solve all these questions and answer me back in comments. Resource I will be adding later on when I will be sharing GitHub link. Today we looked at what is data selection, we looked at how to load data, then we looked at what are general selections, that is list and matrix based selections, how to print columns of a data frame, selecting single columns and observations based on data frame without loc and iloc, then selecting multiple columns and observations of a data frame. After that we looked at loc and iloc based selection, why it is important, what is the major difference between them. Then we looked at selecting single observation based on row index, that is loc and iloc. After that, selecting multiple observations using loc and iloc, and here the difference was very clear to us. Then we looked at how to do conditional selections, we looked at optional steps, then we used single conditional selection and performed some operations. We also saw some interview related questions. Then we looked at how to access new data frame using loc and iloc and what is the major difference between them, and finally I gave you some homework. So guys, that's it for today's video. All the links will be available in the description and make sure that you practice and do your homework. Till then, bye bye. See ya in the next video.